Your mic is on.
Is it not on? Listen, I'll be honest with y'all. I was told IT instructions on a piece of paper, and it was all follow these. So if it doesn't work, I apologize. I'm gonna figure it out as we go. That being said, thank you all for coming and to was it our second ChiPy event this year at Spot Hero. So I appreciate each and every one of you coming, especially after work. I know how draining it can be, right? So definitely do appreciate it. Glad to see that everyone has food and drinks. Please continue that. Like that's all there for you guys, right? So eat more pizza, drink more, enjoy yourself. But yeah, thank you. Like my name is Sahil. I am the recruitment manager at Spire, but we're not here to recruit. We're here to just enjoy a great meetup and meet some people and talk Python, right? So yeah, enjoy yourself. If you have any questions, please let me know. Washroom, so the guy's side is just over there, and then the girls is just on that side around. Okay? If you have other questions, just let me know. Thank you. And I'm just gonna pass it over to our first speaker. Yay. We can give her a round of applause.
Hello, and welcome to ChiPy. Gonna get started in just a minute. First things first, I'd like to direct you to our code of conduct. It can be found on our website if you need some reading material. Basically, we're asking everyone to be nice to each other. We'd like to give some thanks to our sponsors because without them, ChiPy wouldn't. We're particularly, we'd like to thank Spot Hero for hosting us tonight. So for anyone who hasn't been to ChiPy before, ChiPy is a Python-focused community that started in 2003, meeting up at bars. We've now grown to have over 6,000 members. This is our board of directors. I am one of them. Joe's also with us. Do we have anyone else here with us tonight? I think it's just Joe and I. As far as other projects, this of course our Done Your Main meeting, which we hold monthly. We also have the algorithm SIG, which next meeting will be on Thursday, November 3rd. We have the Buddy Mentorship Program, which can be found on our website, and we have a job board also on our website. So if you're looking for a job, check that out. You can find us on Slack, on Twitter, and of course on our website, chippy.org. So tonight we have 3 talks for you. First up is Ali Sivji with Life Without Pip Install. And with that, I'll hand it over to Ali.
Okay. Yeah. Just this is not right. Do I put this on? Yes. Just tell it how you. All right. All right. Let me find my notes, and we can get started. I'm just going to start my timer. Perfect. Oh, you need to share your screen. Am I not sharing? All right.
I get this. Gotcha. Yeah. Where's the Zoom? Yeah, I got it.
Perfect. All right. Well, thanks everybody for your patience while I get set up. So my name is Ali Sivji. I am the platform improvement lead at a company called Jasper Health. We're an early stage startup that is helping cancer patients on a psychosocial basis. We're going to be hiring very soon, so if you're excited about helping cancer patients with Python and with data, please reach out. We'd love to chat. I'm also, I would say I'm on sabbatical right now. Don't really have the time to help out, but I do love Chicago Python. Try to help out as much as I can. And since this is our October meeting, I want to let everybody know I'm a Halloween enthusiast, and my talk is a little bit Halloween or spooky themed. All right, so let's get started. So picture, if you will, a Python ecosystem that has lost the ability to pip install. Every Pythonista is trembling with fear. What are we gonna do? Learn another language that's not Python? Come on now. We all know there must be a better way. So in tonight's episode of Twilight Zone Python Edition, we're gonna explore different ways to channel the supernatural and communicate with Python packages from beyond the grave. All right, so let's talk about what would life be without pip install? I mean, we still got Conda, so let's just use that. All right, so that's it for me. Thanks, everybody. My name is Ali Sivji. Wait, what's that? I still have some more time? All right, I guess we can dig into this a little bit more. All right, so have you ever really thought about what happens when you import a package into Python? So when we import requests, the object that we import, it's going to be of type module. And we can also see the location where this module is going to be imported from. So let's just take another step back. Looking at the documentation, sys.modules is a dictionary that maps module names to modules which have been loaded. We can think of sys.modules as a cache of all the modules that are loaded into our current Python process. Sys.modules from the documentation can be manipulated to force reloading of modules. However, replacing the dictionary will not necessarily work as expected, and deleting essential items from the dictionary may cause Python to fail. May cause Python to fail? Let's go take a look. All right, so when Python first starts up, sys.modules only contains the built-ins, and for packages that are not built in, they're going to be loaded into sys.modules cache when we import them into our Python process. And so one of the most annoying things about Python is that when packages are loaded, they're only loaded once. And if we ever want to re-import a module or a function, we have to restart that Python process. And this makes it really, really difficult to work in a REPL environment. And it's especially annoying with Jupyter notebooks when we have these cells in our notebook that have very CPU-intensive calculations. So working through an example, we'll start by importing custom module into our current Python process. We're going to call a function in that module. It works as expected. Next, we're going to add a new function to our custom module. And now when we try to import this module in again, and we run this function, it's not going to be actually found. So the first piece of bad advice I'm going to give to you tonight is I want to show you how to reload modules. So like before, we're going to import our custom modules into our function or into our process and run a function. It works as expected. This time, we're going to use importlib.reload to re-import our custom package into the sys.modules cache. And now when we call the new function, it works as expected. I really recommend you go out and read that documentation before you use this in your program. And please don't reload modules in production, although it might be a fun idea to play around with. But we still really haven't thought about how can we survive without pip? So we'll start by asking ourselves, how does Python know where to load modules from? So recall when we import a package, we also have the directory location where that module is loaded from. In Python, sys.path, it's a list of strings that specifies the search path for Python when it searches for modules. So when we import sys, and when we look at sys.path, we can see it's a list of folders and a zip file that Python's going to search for when it needs to find something to import. So looking at the documentation, it says that a program is free to modify this list for its own purposes. Is anybody thinking what I'm thinking? So let's try to import request. It's not found. Next, we're gonna find the path of a site packages folder that already contains requests from another virtual environment. We're gonna append this path to our sys.path. And now we can import requests without a problem. And now I know what you're all thinking. How can I automate this process, of course? So let's run a script every time we start a Python process. Recall from the Zen of Python that implicit is better than explicit. Wait, what's that? It's the other way around? All right, whatever, we're just gonna go with it. So this is where the built-in site package, or the site module comes in. And this module is imported automatically every time we initialize a Python process. So when we scroll through this page, we see that Python attempts to import a module named site customize, which can perform arbitrary site-specific customizations. And so our game plan to create an initialization script is as follows. So we're gonna first customize our site packages.py to add that sys.path append code from earlier. And then we're gonna place this file inside of our site packages folder. And now we can run Python like normal. You're probably asking yourself, this doesn't seem like a good idea. Should we really be running an initialization script every time we run Python? I mean, it might not be the best idea, but luckily there is a clean way of doing this, and that's by using path configuration files. And a path configuration file is a file that will append every single path that's in that file to sys.path. And then when the path configuration file, the path configuration file also allows us to run arbitrary code. I don't really have time to dig into it. Maybe we can do this at the next Halloween-themed Chicago Python event. So to configure this, what we're gonna first do is we're gonna create a file with our other environment site packages path on a line. We're gonna make sure this file ends in .pth. We're gonna place this file that ends in .pth in our Python site packages folder. And now we can run Python like normal. This is still slightly scary because we're performing some implicit imports, but actually this pattern is being used in the ecosystem to load things at initialization. Coverage.py actually uses this pattern. If you go to Ned Bouchelder's blog, he has a really good write-up about this. So is any of this, what I'm talking about, really a good idea? I don't think so, but I'm just letting you know what's possible. You really gotta decide what works for you, what works for your team, and what works for your project. We'll just go over the key points one more time. Sys.modules is a cache of all the modules that are loaded into our current Python process. Knowing about this is super useful if we have to do some complicated monkey patching. I wrote a blog post about this a few years ago. If you want to go check it out, we actually got to talk about dependency injection. So maybe we don't even need to monkey patch. So we'll talk about that in a little bit. And then sys.path is a list of all the paths that Python's going to look for to import a module. You can mess with sys.path or the Python path environment variable. And this is going to be useful when you're trying to run Python on machines that are not yours. I actually do a lot of this stuff when I'm running up a Docker image. And we learned about a few different ways we can load code at the initialization of a Python process. And so the last time I gave this talk, the Python package index tweeted back at me and that said that, you know what, it's pretty hard to kill me, but it's really not that hard if you have friends on the inside. And for those that don't know, E. Durbin is the head of infrastructure at the Python Software Foundation. So these are all the resources I came across coming up with this talk. My name is Alush Tedji. Thanks so much for your time. But before I go, I just want to give a shout out to ChiPy. I would not be where I am without this fantastic organization. Thanks so much for your time. I will take your questions.
You said that part of this, the inspiration for learning some of these things came from having to write on a Docker image and other than just being a hacker and because. What other reasons, how did you come across this info?
So the question is like, how did I come across this info? I was having a conversation, this was back in 2019, I was at PyCon Balkans, and we were just like at a bar talking about the crazy things that we do, like loading things into Python. And one guy mentioned that he was using like the site customize to save himself from downloading all his virtual environment dependencies. I think he was based out of Brazil and he didn't really want to download all of that every single time. And so he told me about that and I just started digging in and like 6-7 hours later I had a talk. All right, anybody else? All right, thanks everybody.
Did you help with the instruments?
I think, let's see.
You loaded it, right?
Yeah.
So let's stop sharing that screen. And then
Do it here.
let's share, we can just totally just share that.
Let's see, is there a way
And then,
to?
yeah, so you go here.
Okay.
Is this one right?
Yeah.
Is this one right? Like the full screen?
Yeah.
Okay.
Is there a way to turn off the side window, like the full screen?
Sure. So what do you want?
Like to turn off the sidebar on the, well, maybe that's on mine.
I think that might be on yours.
Yeah, okay, yeah, it's okay.
Sorry, you all good?
Yeah, is this the?
Yeah, you're gonna be moving it through this one. And then the mic should be on for you.
Okay. Hello, Chippy. So my talk tonight, what's coming in Python 3.11. So before we start, let's go with some caveats. I'm not a core developer, and I don't regularly read the core developers' email discussion lists. I started to write this talk a month ago, so it's not the product of a deep dive. It's mostly based on the what's new in 3.11 page that anyone can pull up in the Python docs. And so I haven't used most of these features, and unlike Ali's talk, I have no pictures and no animations. So those who want to go to sleep can start right now. Before I talk about what's new in Python, let's talk for a second about how things get added to Python. The big features come in through a Python enhancement proposal, also called a PEP. And the idea for what needs to go into PEP is usually from the core developers meeting and discussing and people's ideas, and it all sorts of mixes together, and then somebody writes a PEP. The PEP editors accept it, and if it's when it's accepted, it's put on a track. If it's going to be put into Python, it's put on the standards track, and then they talk about it. They have discussions, revisions, as I say, trial implementations, flame wars, occasional personal innuendos. Most of this taking place on the core developers mailing list, some of it face-to-face at PyCon and such. And when it's felt that it's ready, it goes before the Python Steering Council, and they either accept or reject it. But there's another way things get in, and this is the BPO, which is for smaller things than a PEP. The name comes from, there used to be a site, bugs.python.org, but now they've moved it over to GitHub, so that doesn't work anymore. But every bug report, every pull request, every refactoring gets a BPO number. And many of the changes that make 3.11 faster, they're part of a PEP, they're part of a BPO. So what is 3.11? It is currently the release candidate. It's in, the official name right now is 3.11 ORC2. It was scheduled to be released on October 3rd. They pushed it back to October 24th, claiming that they started a week late, and they just didn't feel like pushing it out any year earlier. But in the release candidate phase, the features are considered complete. If anybody finds a bug, the bug gets fixed, the documentation gets checked, And if you are a maintainer of a third-party project, you're supposed to download it, compile it, and check your code against it. Any maintainers here? Ali? Okay, so what's in there? What's new? These are sort of my categories, but they mostly follow how the Python organization put them together. It's faster. There have been improvements in exceptions and in traceback. There's an entire new module to support the TOML markup language. They've done a lot of work with more type improvements in Python. Deprecated modules. Old modules that have been deprecated for a while, they'll now issue a deprecation warning when you do an import of them. We have changes to enum and lots of minor fixes that you'll probably never notice, but I'm going to take a few slides to talk about some of them anyway. So faster. It's up to 125% faster on average. Sometimes it's 160%. Some of the things that make it faster, we have zero cost try except blocks, which I'll talk about in a minute. Greater reuse of stack frames. So if you're constantly going in and out of a function, it'll keep it around rather than destroy it the moment you do a return. We have a direct jump into C for common Python built-ins, like if you're taking the length of a string. The adaptive interpreter is very interesting. I think I'll talk about that. I think I've got a slide for that. And they've inlined a bunch of the Python function calls. Dunder get and dunder get item. These things retrieve items from objects and lists, add stuff to a list, and some of the other ones. And of course, this won't help you if your code spends most of its time in C, which means that NumPy and scikit-learn are off on their own. They don't get helped by this. Or if your program is spent waiting on I/O. Teach your users to be faster on the return key. So the improvements to exceptions. And I put the PEP number in there for those of you who want to look up more information. We've got multiple exceptions, and they can now be propagated together. Some examples of where you'd want to do this. You have async tasks, and you're doing a wait on multiple async tasks, and they fail differently. Now you get an exception group back, and you can look at each exception in the except group, and we have an except star syntax in the catch block so that it will catch an exception group. The other thing we can do with exceptions in 3.11 that we couldn't do before is add a note to them. We have a add note function which can be put on an exception, and each exception has a dunder notes attribute which holds the list. So when you catch an exception and you're going to re-raise it, you can add a note saying, hey, I saw this one, and they warn that dunder notes is not intended to carry structured data. So don't stick JSON in there. They don't say why, they just tell you not to do it. So as an example, we have a try block, we raise a type error, and we catch the exception, and we can add a note and then re-raise the exception we just caught. So that when your traceback gets run, you get the type error and the information about the type error, and then you have another line with the information that you're going to have. So, for example, if you have a line of Python code, a sub x sub a sub b sub c sub d equals 1, this is very frustrating. You get a type error. None-type object is not subscriptable, and you've got no idea which error it is. So you fire up the Python debugger and go in and start looking for it. We will now get a line of tildes and a bunch of circumflex marks showing you exactly which object in the list it is objecting to. And this will continue if you were calling. It doesn't happen just at the bottom of your stack. It will continue up the stack if you have similar nested things in your stack. This required a bit of manipulation of the information that the exception records about the error so that it knows not only what line it fell on, but which call within the line the exception occurred on. Now the TOML, which stands for the obvious markup language, and was written by a guy whose name is Tom and his the last initial is L. Just coincidence, I guess. It's used like things you might be familiar with, JSON, YAML. It has a limited number of types: lists, dicts, strings, ints, bools, date times, floats, or decimals. And it has been for a while the format of choice if you were doing a package. And you'd write a pyproject.toml. And there's an official toml.io website. The description on that website is a config file format for humans, a minimal configuration file format that's easy to read due to obvious semantics. Designed to map unambiguously to a hash table. Well, I don't know that JSON or YAML don't do that, but this is an example of a TOML document. Everything is at the top level is a dictionary. If it's in a square bracket, it's a dictionary that dictionary element holds a list. The list can hold other lists, and you can have other types, which makes it easy to read. And oops, there we go. The reason they added it as a standard module is that a lot of Python tools have been taking it up and have been using it. There's a list of some of them, and they did a search on PyPy and found that there were over 2,000 projects that included the various third-party TOML packages. For the moment, it's only got two calls: load, which loads from a file, and load s, which loads from a string. And so it won't write TOML. You still have to call one of the third-party packages to write it. But this means that there are very few security concerns. It's pure Python. You can't load classes. Input must be UTF-8. You can't specify anything else. Okay, and now we get to types and typing. And I'm going to be bold here and say that I don't really understand the emphasis of typing in Python. That the type system is so complex, it is a programming language of its own. And the first link I give there is a paper that proves mathematically that Python typing is already a Turing complete language. The second link is somebody who took TypeScript, which also is Turing complete, and actually shows how to write programs in TypeScript's type language. But I would like to say that in 20 years of Python programming, I haven't encountered an error that typing would catch that a good unit test wouldn't catch. Now, admittedly, I don't write packages, and I'm not trying to make things totally bulletproof. Types are currently very much a thing that computer science specialists are spending a lot of time on. If you want provably correct programs, you definitely need typing. But for my purposes, I don't understand why we're spending so much time on it in Python. But let's look at what they did with it. We've added a self-type. And so this is useful if you have something like the example at the bottom. You have a linked list where you want to limit the elements of the linked list to a particular type or subtypes of that type. And you don't want to allow other types in. You can specify a data class of linked list with a type T, and then say the next is a pointer to self. And you don't need to specify that it's a pointer to T or its descendants or something. It makes it a little clearer. In 3.5, they introduced the type var. And in 3.11, we get the type var tuple. So you can parameterize with an arbitrary number of types, which they call a variadic type. And this allows array-like structures in NumPy and TensorFlow to be type checked. I personally, this is a little deep for what I do, so I'm just going to continue on. But for the example they give is you have a function toGray, which takes an array of information about videos. But it's ambiguous as to what the array should contain. You can now specify it's an array which has these elements and only these elements, and then those are type vars. Um, 3.8 gave you a typed dict, which allows for type hints for dictionaries. And in 3.11, we're going to have a support where the dictionary value depends on the string value of the key. So we can have a class movie, which is a typed dict. If it has an element called name, it has to be a string. And if it has an element called year, it has to be an int. And those are the only things that are allowed to be in a movie class. And so by default, all the keys must be present in a typed dict, but it's possible to override this if you specify total equals false, then you can have any of the keys omitted. you can still not add other keys. And, gee, I seem to have stuff off the bottom here, but yeah. If you want to have some keys that are possibly there, but you want to but you don't want to allow all keys to not be there, you have to create an array of types, or I mean a hierarchy of types. So you have a total equals false type, which specifies the things that can be optional, and then you have one which is total equals true, and all the things that are specified in there have to be in there, but it can be descend from a higher type which had total equals false. This to me is getting to the point where we're spending a lot of time writing types rather than writing code. But we also now have something in 3.11 called a literal string. And this is so that we can specify that we don't want variables added into our string. And this is useful for preventing SQL injections. It's also useful for shell commands that you're going to pass to subprocess, and possibly for dynamically building HTML, JavaScript, etc. So an example, we have this function query data. It has a literal string to it. And the rest of the example is off the bottom of the screen. I'm not sure. You're going to have to download the slides if you're really interested. But down there it specifies that you can add a literal string to a literal string, and it will still be a literal string. But you cannot add a variable to a literal string, otherwise you just have a string. We have data class transformations. And data class objects create their own init functions in addition to other dunder functions. And this PEP says it is a start on specifying the manipulations of a class that a type checker would see as legal. This is needed for library functions and for decorators, and allows more complete specification of type coverage. And really, this one was totally beyond me. It really feels like you're doing a lot of work to get your type checking to work where your code would be pretty simple. Okay, the deprecation warnings. I sort of like this quote that the standard library modules aren't always the best choice for a job. Some library modules were quick hacks. Some were designed poorly and are now nearly impossible to fix. And some have been rendered obsolete by other more complete modules. So back in 2019, they deprecated a bunch of modules. They are scheduled for removal in 3.13. This, starting with 3.11, if you import them, you will get a warning printed out on standard output. And how they do that, you can go back to Ollie's talk. They hook the import function. But these are the deprecated modules. Most of them don't even recognize. things like async chat and async core have been superseded by async IO. CGI has been recommended that you avoid for 10 years now. It starts up a completely new Python process for every call to the web server. Crypt was the old Unix password encryption, which is considered very breakable these days. Oh yeah, Sun AU under the multimedia was if you had a old Sun workstation and wanted to play audio. We also get a number of things with enum. Enum was added with great controversy about, what was it, 2.5, 3 years ago. And now they're finding that enums are difficult to work with the type system. So most of these changes are things that allow the type system to work with enums. I'm not even going to read all this to you. There's a lot you can see. We have decorators member and non-member. I'm not sure, I don't know, I haven't used enum enough to understand why you would specify something in enum, but it's not a member of the enum. But these are all decorators and properties. And it keeps going. There's more. You can have string enums where the enum values must be strings, and repr enums, which causes only the dunder repr to be modified. Flags, you can have enums, which are bit strings. Let's see, I think I'm going backwards. It's easy to get bit. Okay. So some of the other changes, minor fixes that you'll never notice, new methods that they've added to existing modules. Over 24 modules had some change made to them. Small syntax changes, optional parameters, changes to optimization, and changes to the C API. Example of minor fixes, they've made a lot of changes down in the Python C code. Compiling now requires a more modern C compiler. It uses NaN that's part of this modern C compiler's math functions rather than its own NaN value. And it removed a bunch of C functions. Some examples of changes in the existing modules. Anybody ever use the turtle module? Oh, we got a few. Set tilt angle is deprecated. Instead, use the tilt angle function. The unit test module added a method called intercontext and interclass context. And when you call them, they automatically put in an exit for the context, which will allow you to collect information about the tests that are being run. And the regular expression module, RE, since 3.6, they've added a number of controls over backtracking during a search. And we now have qualifiers in there that say, if you get to here and you can't go any farther, don't bother backtracking. So this should help if you understand what you're looking for to come up with more performant regular expressions. Another example of a syntax change is if you have a with statement and you call it on something that does not support the with protocol, instead of getting an attribute error, you now get a type error. And my favorite, for V in star A star B. This was discovered to work after 3.8. They didn't intend it to work. It was a side effect of some changes they made in the way it was parsed. Now it is officially supported. Yeah, question?
Assuming that A and B are iterable, basically it iterates to A and then to B.
Yes. Yes, it iterates through the elements of A and then through all the elements of B.
So for 3, you have A, B, and C.
Yeah, yep, works for any number. You just have the commas in there. It creates an implicit tuple. Show util RM tree. This adds a auditing event. Auditing events are something that if you're concerned about changes that your Python program might make to its environment, but you want to allow them, you can set up auditing, and most of the APIs that modify the environment write auditing events to an auditing log, and apparently RM tree somehow got missed. And sort of interesting one, glob, which is used for searching directories by name or the names of files within the directory. Now, if you end it with the file separator, the path separator character, like a slash of some sort, it will only return directories. So you can look at, you can ask glob for the tree, but without the leaves. Okay, in optimization, we have a lot of little things. I've talked to about the length is compiled directly to be a C call. The interpreter can now recognize if you have a complex bit of code at the bottom of a loop. If you call that, if you're going through that loop a number of times, it will say, I need to compile this into something more efficient, rather than calling the Python bytecode each time. It's sort of like a JIT, but they say it's not a JIT because a JIT would do this ahead of time. This is only activated when it recognizes that it's needed. And I was also going to talk about here the zero cost exceptions. In current Python, if you hit a try block, it puts a little bit of information on the stack, and then when you exit the try block, it takes that off. A zero cost exception, when you hit a try block, it doesn't do anything. There's a marker in the code, but it doesn't actually generate any activity until it throws an exception. At that point, it searches back up and cuts, and then you pay the cost for the exception. A lot of the APIs in C have been changed to static inline functions because they find that they're much safer to use. And if anyone has ever used macros in C, you'll understand why you don't want to use macros in C. And a number of the things that were static inline functions, they've changed to regular functions because they were complex enough. They found that there was no time advantage to making them inline. So, should you upgrade? Speed is the real reason to move to 3.11. It is supposed to be much faster. If you're using types, you probably want to move to 3.11 so you can get advantage of all the changes they made to the type system. I like being able to put notes on exceptions. I've had a number of cases where you get an exception, it raises something. If the accept block raises another exception, your traceback says, oh, while handling this exception, another exception was raised, which looks like you have an error in your exception block, but you don't. Now it's possible to just add a note in there. And also, I think the fine-grained traceback information will be very useful. And most of the small things, you won't find them useful until you have a need for them. You go into the documentation and you go, oh yeah, it says added in 3.11. Yeah, this would be useful. It's just what I need. So there's the link to my slides. They're up on GitHub. That's me, Phil Robert. I have no Twitter, I have no LinkedIn, I have no Facebook, Instagram, Pinterest. You can DM me on ChiPy Slack. And that's it.
Any questions? Yeah.
Yeah, hold up your hands.
Oh, yeah.
There it is.
Did you happen to notice that they said up to 20% more memory usage in 3.11?
Nope, I didn't notice that.
Yeah, just a heads up. I noticed that while reading the faster Python, CPython link from the main PEP. It was curious. They say it's offset in some areas, but it seems like a lot to me. I don't do anything in production, so I'm not terribly worried about it, but I figured I want to have a look at your memory usage.
Okay, yeah, I think this is more an answer to AWS, Python, where memory is cheap and execution time is what you pay for. Any other questions? Okay.
We have a question online. Question is, do you know if it's faster than MyPy? PyPy.
No, it is not faster than PyPy. Compilers always beat interpreters. Yeah.
So I guess I have a question about TOML files. I think this is like the first time I've heard about them. I mean, I haven't really messed around with configuration files that much, but is TOML supposed to, I guess, replace YAML or JSON, or no? Is it like something that's specific just to Python?
I'm sorry, so what's the question?
Like, so I'm not really too familiar with configuration files. Is TOML just supposed to be something that's just specific to Python, or?
No, TOML is not specific to Python. There are implementations in multiple languages. The toml.io website has links to all of them.
Okay.
But it's supposed to be rather simple and straightforward to use.
My understanding, JSON's really machine friendly. YAML is not typed very well, so TOML is the result.
This is a question for everyone who raised their hand, but what is that tilt module? Like, there was something about setting tilt angles. Like, what is that? I've never seen that in my life.
Oh,
Turtle, yeah. What is this? It's a plotting library?
Yeah, Turtle is a plotting library.
Okay.
People learn Python.
Interesting.
Little turtle go around in this.
There you go.
If you're really going to do plotting, you import Matplotlib, do your plots there. Turtle,
I have the goal of using Turtle to make a pop presentation. Turtle is my goal.
We're going to have a break now, or?
We'll take a quick break and be back.
Eat more, drink more, please. Is it loaded up on here already, Joe?
I think we need to.
Yeah, straight ahead. Stop sharing.
I still will be using his laptop.
Okay.
And maybe we just need to.
I just have to send in that to and that's it. So we're all good to go. Otherwise, how's everything going so far? Like, should we make?
She's all right. We've been checking a little bit.
Yeah. Are they hearing okay? Okay, cool. Yeah, if the mics don't help, let me know. Okay.
Thanks for your patience.
Yeah, no, of course. Listen, this is for you guys, right? Like, I want to make sure y'all are good, right? Like, so let me know what else you need from me, and then we can just set up whenever you guys are ready. Like, please also crank and eat as well. I know you're busy organizing. You also what you need to do as well. Yeah.
So LED library, SSA, then what
Hey, what's up?
Yeah.
Okay. Yeah.
Yeah.
And so like.
it's like I just see my kid. So like the way I would probably do it.
Okay, I'll be fine. Okay, but we need to connect the display, I assume?
Yeah, so we just say the Zoom invite and our 5-year-old friend.
Well, I don't need my that's fine.
You'll find it. So the I'm not familiar with Zoom or they don't use all of them.
You can send me the link.
Yeah.
You just go to participants, you can probably invite me.
It's my wife's computer, so it doesn't. Let's see.
I will need Wi-Fi because I need to connect those two.
So right on the front of this, there's Wi-Fi on the front of the podium. There might be on this too, I don't know, but let's see. Oh, here.
I would watch that. It's gonna blow your mind. It's called packages or even less packages. It's fantastic. Like you'll come up
Hey, what's your, I'm gonna get you to just type in your email and then just sign in, and then at that point, I'll just get you, you can just jump in on Zoom, and then we can get you to share the screen.
Well, that's okay, maybe that. I thought maybe for a really large person, those are good as one shot. You need to always have the lights, lose all of it. But I found out the rest I'll think that maybe you could.
Should have sent it to you.
Oh, yeah, just got it.
Perfect. You're able to join in, and then we can be able to share. So don't join audio. What? Don't join audio. You're good.
I'll just use that to share my screen.
Yeah, exactly. So just if you're able to share your screen, you're good to go. And then I think we have a mic for you as well. Just call me if you need me.
that way it was a little
Everyone, hello.
It's audible anyways.
Hey everyone, we're gonna get started in just a minute. So find your seats.
Also, Joe? Hey, Okay, cool. So my name's Adrian. I plan on talking today about dependency injection. My goal is to demystify things a little bit. I've only ever talked at smaller meetings, and so I didn't make slides. I was going to just live code this. It'll be interesting with a group this big. We'll see how it goes. But yeah, so who here hears the word dependency injection and thinks like bad or complicated or Java or something, or like I have no idea what it is? For some of those, okay. So the goal of this talk is to show you that it doesn't, just because it's like this complicated thing that you do in Spring Boot doesn't mean that it's a pattern that doesn't make sense in Python. And in fact, you already use it in Python. You just probably don't know where. And it's really easy in Python because in Python we have first class functions, we have first class classes, we have partials, we have all this stuff that makes it really easy to pass things around, because really that's all it means. It just means pass things around. But I don't want to just talk about things like an abstract, especially in this topic. There's a lot of terminology and mumbo jumbo and it gets really complicated. So I just want to like look at some code together. And we're going to just kind of work through it. I'm going to explain maybe what some of the problems are with it and how you can use dependency injection, which again is really just passing things around, to make this a little bit better. So here's a piece of code. I work at an insurance company. I work on a team that does property data. And so we have stuff like this quite a bit, right? Something like getting the data for an address. And we might cache it somewhere. Like maybe if we already have that data in S3, we cache it because we pay for every API call to this gisexample.com. So, we want to cache it. If we already have it, don't hit them again, just return it from the cache. Pretty straightforward. What are the issues here? How do you test this code? How do you, like, for example, test that if it's cached, we don't hit the GIS service again? This is a pretty simple example, so you can kind of look at it and see what is correct. But if there's a bunch of business logic wrapped around this, you might lose track of, your conditions and stuff. And so you probably want to test this stuff. But you can't hit the GIS service in your tests, especially not if you're paying per API call. It might be slow. You might not want to have this GIS auth token floating around your tests. So what would a test that I've seen and have written as well for this look like? Well, it might look something like this. Use the patch decorator from unittest.mock. It automatically creates a magic mock object and injects it as a parameter when used as a decorator. And so we get these objects here, and then we're gonna have to go and say, well, when you call the get function, the return value is actually another mock. And then when I call raise for status on that mock, I return none because I'm testing the case where there's no error, but it's not cached. And okay, you get the idea. There's a lot of mocks going on here. I get guided by my ID for starters. And looking at this, I kind of have no idea what's going on. There's a lot of red squiggly lines, and I can't tell what is being called and what's even really being tested. Like most of the lines of code here are just magic mock stuff going on. And so that's kind of a problem. And here's a more concrete problem aside from my personal preferences. Another developer comes 2 years later and decides to do a perfectly logical refactor. Like, well, look, you're only ever calling storage.log from this Google Cloud Storage module. So why don't we just do this? And first I'll run this test, and unless I broke it, yeah, it passes. Okay, great. My test passes. So I'm going to say from google.cloud.storage import blob. Perfectly reasonable. I'm going to replace that there. And okay, perfectly reasonable. The code should be equivalent. But what happens to my test now? Bam, breaks. Why? Anyone have any idea why it broke?
We mocked the wrong thing.
Well, no, we patched the wrong thing. Because there's a difference between mocking and patching. And I think it's really unfortunate, personally, that this patch function kind of mixes both concepts for people. So really, there's two different things going on. One is patching, the other is mocking. What this patch function is doing is it's creating one of these magic mock objects and then going and assigning it to this value. So it imports this module and reassigns that value. So it's actually doing two things at once. But the problem in this case is patching, because we told it to come and replace, we told it to patch demo.main.storage. What happened? Demo.main.storage doesn't exist anymore because I just changed my import. Now I'm importing blob directly. That's like one example of where things get fragile with the setup. With this, mocking setup. Another issue might be, just changing. Yeah, it's going to be just changing implementations, hard to understand tests, and those sort of things. So the question is, what can we do here to change it? What can we do to make this not break when that happens? Or what can we do to make it easier to test? Sometimes another reason you might want to change things is, well, what if you actually move to AWS from Google Cloud or vice versa? Which I don't know if that's happened to anyone here. It's happened to me. I've had 2 jobs, and both of them, when I got there, they were like, we are doing a cloud migration right now. Good luck. So yeah. So how are we going to change this? I kind of have a game plan of where I want to get to, but I don't have first I'm going to edit this, then I'm going to edit that. So I'm going to kind of ask you guys, what do you think we can do first to avoid the problem we just saw, or to just move this forward? Any ideas? Because we can go many different ways here.
Maybe if you try to import the module in the test and do module name _name plus and then the thing. So if you move things around, it won't.
Yeah, you mean basically what I had before instead of importing blob.
Yeah.
Yeah, that's one way to go. I think a really interesting thing I've seen that is similar, that is the form of dependency injection, because again, it's a very vague term, is if you look at actually some of the Google libraries, they do this, which is interesting. I just overrode the global with this local, which has a default value of that global module. So one thing I can immediately do is I can say, instead of using this patch decorator, I can say, I can say mocked, and I'm mocked storage equals magic mock. And here I can now say storage equals mock storage. And now my test should run and work. And now what happens if I change this? Google dot, what is it? Google.com. Well, you'll see already I'm getting errors here. There's an undefined variable. In fact, I won't even be able to import that module. There'll be a PyTest import error because you can't even run this module at all now. So you just move the error from like some weird, like your thing wasn't mocked, and so you actually called into Google Cloud Storage and you got a credentials error or something or whatever was happening before, to like, yeah, this symbol's not defined, which very obviously links it to the change that was just made here. So that's one way you can do it. And the reason I think that's interesting is you can't do that in other languages. You can't like import a module and set it as the default value and then pass in a parameter to replace that, because it turns out in Python, modules are just objects and they have attributes, and yeah, you can totally just replace a module with a class or do whatever you want, really. And yeah, I mean, I see this more commonly with like requests. Like requests will be assigned as a default value, and so you can, instead of like monkey patching requests, you just replace the default value. But along these lines, we started doing a little bit of dependency injection, but I think we can do a little bit better, because one thing you'll notice is we don't actually need, like this function doesn't actually need the entire Google Cloud Storage functionality. And in fact, what happens if I do something like this? Storage.bucket here, right? Like I modify the function and decide to do something else. Well, basically what's going to happen now is I'm going to be calling unpatched things I'm going to be calling to my mock, to things where I didn't set a return value, and we get like another magic mock object back, and like weird things are going to start happening. So one thing that you can do, which is very helpful, is to essentially declare what functionality I'm going to use. I'm going to reduce the interface of the Google Cloud Storage library, which currently is the entire thing, to just the smaller piece I need. And there's names for this sort of pattern, but really, it's not that crazy to do in Python. So I can make something called a bucket, which is going to basically do the same thing that we did before. Let's start with that by saying something like, I don't know, maybe I have a name and I have storage equals storage, just like I had before. And now what do I actually need to do with the cloud storage class? Well, I'm checking if a blob exists, I'm uploading, and I'm downloading. So I might write something like exists. I'm gonna leave that out for now. Or maybe like get key So now if instead of implicit, like creating this dependency on the storage module internally, I'll explicitly declare what I depend on, which is going to be this bucket. So now I can say bucket.exists. Probably need to add a key here. Address. And I'm going to say bucket.get address. And then what else do I need to replace? Here I'm going to say bucket.put. And I don't need that byte type thing anymore. Oh, address. Okay. So I haven't implemented anything here yet, but I mean, it'd be pretty easy to implement. I just say something like self.bucket equals storage.bucket name equals name. What is it missing? Storage.client, something like that. And then here I can just say self.bucket.blob key.exists. Sure. Return. And then here might be return self.bucket.blob key.download as bytes. And this will be return bucket.blob key.upload from file. Okay, so really all I did was I moved some complexity into this bucket class, and I declared explicitly what I need from a bucket in my get data for address function. So what does that actually let me do in ITEST? So I'm going to import from here my bucket, and because I can subclass and do whatever I want, I'm going to say my in-memory bucket is a bucket, which is initialized. I don't even care if it has a name or not. I'm just going to say self.data equals a dictionary, and then I'm going to say get. And now we get into an interesting conversation about what is this thing? What is this in-memory bucket? Because there's a lot of different things that you could substitute for your dependency. One of them is a mock object, and that's kind of what we were doing before with except with patching, but we could continue to use mock objects. What I'm writing here is more along the lines of a fake, in the sense that it actually has some functionality. It doesn't just return canned values. But the other very common kind is when you do return just a canned value, which I'll get to later, and it's commonly called a stub. And so the whole dependency injection thing is with tests is just you don't instantiate that storage client yourself. You let that be passed into you. And in your test, you replace it with some sort of test double if you need to. You don't always need to. And so, yeah, what I'm missing here, I'm missing put, which is going to be self.data key equals data. Okay. And so now if I come here, you'll see that my ID is already telling me that I'm not passing in the parameter bucket for here. And so I need to create a bucket and pass it in. So I'm going to say bucket equals in-memory bucket. And instead of passing the storage, I'm going to pass in bucket equals bucket. Now my ID is happy. And I can get rid of some stuff here because I no longer need to have mock storage. I no longer need to have that. No longer need to have that. But I do want to add an assertion here, kind of what I had before. Bucket.data equals, what do I have? 123 Main Street, Chicago, Illinois 60601. And I want to say that this is equal to this test data I have here. So I'm just going to move that up there. And I can probably just write out the bytes for this. Well, I don't know what JSON.dumps is going to say, so let's just do this. Okay, cool. And I don't need this anymore. Let's run this and see if it works. Well, it didn't work because, yeah. What did I do? I don't know if you guys debug tests when you write them. It's extremely helpful. And I'm getting a call from my mom now. Great. Okay, well, I'll spend a sec figuring out why this isn't working. But the basic idea is, okay, now we have this bucket object and we're passing that in instead of doing our monkey patching and our mocking. And guess what? We can do the same thing for our HTTP client because we're still patching that and we're still making these calls. And furthermore, one thing that you'll realize, aside from the ease of testing or whatnot, I have like authorization going on in here inside of presumably my business logic. And authorization is kind of a very HTTP thing. There's no reason for that to be polluting my business logic. So one of the advantages that we can get here is actually getting rid of some of that, stuff going on in there. So we have a couple different ways to go here. One is we could do the same bucket thing I did here, basically the same thing, and do some sort of class GIS service. So that's one option we can go here. Another option is to actually just inject the client. And so we can just say httpx.client, and you can do the same thing with a request.session. And now we just replace this direct call with that. Okay, that's a place to start. So let's see, let's go back a sec and see why this was failing to run. Oh, this shouldn't do it. Let's see. Storage was storage. I just want to figure out why that test didn't run. Oops. All right, what is it saying? No test results, okay. What is it complaining about? Syntax error somewhere, okay. That makes sense. Yes, this is not valid syntax. There we go. Okay, so now hopefully this will run. Okay, cool. I think that will fix it, hopefully. Sorry if I'm jumping around too much here. Okay, so now we're getting our bucket. Sure, we call our function. Things crash. What did I do? Type error. Get the address missing one required positional argument client. Oh, because I just added this other argument here. So yeah, so let's. Well, fine. Actually, no. So I needed to add this here. Let me reformat. Okay. Let's see if this works. Well, it doesn't because I am now making an actual HTTP call. So we're passing the client, but now we can't really mock it anymore. So what we could do here is say, pass in mock HTTPX. That maybe will work. In-memory bucket has no attribute bucket. Okay, so my in-memory bucket implementation is bad. Oh, I didn't override exists. There you go. So there's better ways to do this, but I'm just cowboying it right now. So I'm going to say I'm trying to do the self dot or key in self dot data there. Now we have an implementation.
Return.
Oh, yeah. Well, I happen to want falsy, so I return none. That's what type checkers are for. Okay, so now this is passing again with my mocked HTTPX client. So the question is, how can we clean up some of this mocking going on here and move some of that HTTP stuff out of our business logic? So what we can do is we can actually create an HTTP client, which itself uses dependency injection to inject into it the logic we want without any mocking. So I'm going to write you'll see if I create a client, the client actually takes a parameter. Well, let's go to the client. Takes the parameter called a transport. And there's a convenient transport that is httpx dot mock transport. And this transport takes a handler, which takes a request and returns a response. And so I can just return here on httpx dot response with status code 200. And what else do I have to put in here? Content. Yep, content equals my JSON dumps test data. And I now have a mock client. And so I can pass that in there. And I'm ignoring the request argument. For now, that's, oops, daisy. That's fine. But I can get rid of this patch. I can get rid of this stuff. Let's see. And my test should be the same, hopefully. Passes. There you go. You can even probably maybe stop it in the debugger here if you wanted to. Yep, there you go. I can stop in the middle of my request response function, which just happens to be a Lambda, but it could be an actual function if you have more complex stuff going on in there. And the really nice thing about this sort of approach is now it's super explicit when I'm testing. Like if I wanted to write a test, like test get address does not exist, I could write the test and come here and write status 404. And you look at this and you're like, okay, what is going on here? Well, my dependency is returning a status 404. Cool. What else can we do with this? So what if we want to get this authorization logic out of my business logic here? You'll see my little example here is now also complaining because it's missing parameters. But what we can do here is we can say something like client equals httpx.client. And instead of passing in a transport, we might say headers equals basically what I had here. Oops. Headers equals that. And we might even say like base URL equals, I don't know, something loaded from environment variables, example.com.
Too many slashes.
What? Sorry, what was that? Oh, too many slashes, thanks. Funny enough, I saw the author curl saying the other day, there's no specification for how many slashes you have. So apparently you can have 100 slashes and that's a valid HTTP URL. So don't write a URL parsing library. You will get it wrong. So yeah, so now I can actually delete all this stuff, and there is still HTTP stuff going on here. So we could like take this a step further and actually like remove the very notion that we're making this request over HTTP. But for now, at least I removed like all the authorization stuff. And like, I'm like, okay, I'm making an HTTP request to this, to a slash address. That might be like addresses, if this was a real addresses or something. And I don't know. Removed all that cruft from there. And my tests are still just simple because in my tests, I don't really care about that authorization logic. That's not what I'm testing. I'm trying to test my own business logic. And so I can just get rid of all that stuff and not, not worry about it. But if I wanted to write a test, if I wanted, to test how I'm interacting with this bucket, the other thing I can do now is I can import this bucket class and test that directly. If I want to test, again, like the 404 situation, I can just override status code 404 there. And probably not return any data or something, but it becomes explicit when I'm testing. And the ultimate test, right, which was, well, here like this storage thing, it's still the same. I'm still passing it in a parameter here, but if I change the import now, my tests don't break. Or it breaks here. That was kind of the thing I wanted to walk through. Any questions or like, what would I do in next situation? Yeah.
I guess it's more just like, instead of mocking out an HTTP, like, have you thought about maybe using like a library like vcr.py to record your requests, and then when you play your request for test, it would just replay those request responses. So you make one request once, but you never do it again.
Yeah, that's a sort of thing that's called snapshot testing. I don't know how that, I've never used vcr.py. I don't know how it actually like hooks into like requests to do those replays or something. Does it monkey patch stuff.
Yeah, I imagine a monkey patch is behind the scenes. I haven't looked into it. Like I've used it, but like,
Yeah.
what are your thoughts on doing that versus dependency injection?
Well, I think they're kind of orthogonal things. Maybe that library monkey patches. Dependency injection is more an alternative to monkey patching than it is to mocking or snapshot testing or any of those sorts of things. It's not really one or the other. I don't know. That library may tie you into monkey patching, but that is almost kind of an implementation detail of it, I'd say.
Yeah.
Someone could totally come and write a mock transport where you like point it to a file. Like you can imagine I have like httpx.snapshot or something, and I say like this is like tests something. I don't know the name of this test or something. And it does something like, oh, if the file exists already, then I just load the data from there. And if it doesn't, then I make the request and I return the data. You could have something like that, but I'm still using dependency injection here, even if I'm doing that sort of snapshot testing.
That makes sense. Thank you.
Yeah.
So I was thinking this, sorry. So one issue we have with the tests is that the Pylance type checker doesn't like the fact that there exists classes it doesn't know about with attributes that's generated in runtime. Instead of directly calling the client class, you could enclosure it within a function, let's say get client data, that it basically does all the authentication and just passes through the address so that it doesn't even pass through the address, it just encloses it and returns a function that's just a pure client.get function.
Okay.
But it encapsulates all the authentication, all the steps you did before. And with that, you just need, in the test environment, you just need to replace that function with your test function.
You mean something like this?
Like get client, or you don't even have an address, you would have like the token. You would do all the token authentication within that class.
Okay.
And then you would return just client.get without any preferences. And then you can use, and then within get data from address, you call get client getter, something like that. And then you call that and it'll actually enclose stuff and close everything.
I'm sorry, I'm lost, but it's not because of anything you're saying. It's just hard to follow closures.
Yeah, it's a functional concept.
Yeah. Yeah, I mean, you may totally have a good point. I just can't follow closures like this.
No, closures is almost exact same thing. Closures are almost exact same thing as dependency injection. It's just instead of parameterizing it within the arguments of a function, you basically parameterize it when you import, when the Python interpreter reads the code the first time. When it builds out the bytecode, it adds it in.
I mean, I get what a closure is. I just can't really see how we're using one. But also, it sounds like you're almost like talking about querying, where you're like taking a function and like citing some of its arguments. Yeah, you can also do that with functools.partial without a closure. So yeah, I mean, you could like query httpx.get with the all. Is that what you're saying? Like, yeah.
So you turn it already off.
You mean to remove like the business logic from in here?
Or we remove all the. You can also have like.
So I think you're saying something like this, like get equals partial httpx.get auth equals, or sorry, headers equals that, something like that, and then calling get in here, something like that. Yeah, I mean, that's definitely another way to get rid of the business logic. You still have the business logic up here, and I don't know. I mean, it's one way to do that. HTTPX just already itself provides you a way to do that via client instances. It's basically what it's doing. It just saves that attribute on the class, and every time you call get, it injects that. Because yeah, you can also just create like the client here and say like client equals headers equals blah blah blah. You just create that there, and then not inject it as a dependency. And yeah, you got rid of that. There's some issues with that. Like one thing that's going on here that I personally don't really like is getting environment variables at import time. You'll see I did this get end thing, and that's because if the environment variable doesn't exist, it'll just get assigned to none. It's the same as calling environ.get which is just a dictionary, so the default value is none. So you'll see my type checker will tell me this is string or none. And that's just so that you can import the module without setting environment variables. But that's kind of a pain because you'll notice there was a bug here where this value could be none. And so now I'm passing it into a string. What's this going to do? It's just going to call like string on none. So I'm going to be sending bearer space none as my authorization header. So yeah, I don't know, sharks lurk there. I think one of the advantages of passing a client instance is that you can not import, because you don't have to have a global object to reference then from within your function. So you don't have to have this value here as a global. In fact, you could just move this into your name equals main, and then instead of a get, you can just do that, because if someone's running this as the main function, they should set that environment variable.
There's a promise maybe with closures that you could have all the authentication, even if it's complex, like Kerberos off to where you have to send a token, receive a token back, solve a problem,
Yeah.
send it back and get the final token.
Yeah, I mean, but that's kind of the same thing as passing a parameter to the HTTPX client.
This can pass a function.
Yeah, well, it is definitely an interesting thing. Like I said, in Python, you can kind of do whatever you want as opposed to other languages. And so, yeah, you can totally like query a function and pass that function in as a dependency or something. And I think like interesting examples of that are like if I do like import JSON, right? And then I do like JSON.loads. This has a ton of parameters. It has a class, which is a JSON decoder. That's one form of dependency injection. It's letting you inject a JSON decoder. It's allowing you to inject an object hook, which is a callable that takes a dictionary and blah, blah, blah. So yeah, you can do all kinds of cool stuff in Python. Like you can say, what was the parameter? Object hook, which I think is like a function that gets called when an object type, I don't know, it's something that gets used in
Each JSON object gets called with
that. Great. So yeah, so we can call something like obj and then like assert not is instance obj. I don't know. And now this is just going to give an error every time you try to serialize a float. But like, yeah, you can dependency inject the Lambda function that you built right there, and you can do that inside Clojure or inside whatever you want, because everything, you can just pass things around as much as you want in Python. And that's one of the beauties of it, and one of the reasons that, you know, you see like dependency injection in the Java thing, and then you're like, I don't see this pattern in Python. It's because the pattern is so thin that you don't even see it. It's not because it doesn't exist. It's just because it's there all the time, but it's so void of boilerplate and ceremony that you probably just use it and don't even realize that's what it is.
Can you get a quick vocabulary lesson in curry?
Yeah, so currying is basically, have you used functools.partial?
Maybe. Let's say no.
Let's say no. So currying is where you have a function that takes parameters A and B, and you want to fix B. So for example, let's say I want to create a function that adds 1 to a number, right? But I have this function. I have the function sum A and B. So I have this function from the standard library or something. And you can imagine, obviously, it's a trivial example, but you could have a much more complicated function that takes more parameters or something. And I want to create a function that just adds 1 number. I could write a function def add 1, which takes a and returns another number, and then calls sum a1, right? That, or return. Oops. So that'd be one way to do it. The other way to do it is with some kind of currying. And so there's a lot of ways to curry things in Python. One is when I mentioned functools.partial, which let's see if it'll import it for me. So if I say partial sum b equals 1, this is now an equivalent function. And so I can just call this with, let's say 2. And if I print this value out, well, let's run it like this. Oh my God. I blow up my text to make it readable, but then you can't read anything. What did I do? Someone said something I did wrong?
You gotta implement some. Oh, wait, never mind.
Oh, I have to implement some. Yeah. It's doing nothing. Cool. Now this should work. Great, 3. So I just curried the argument b equals 1 into my function sum. And because Python is just that flexible, you can also do something like, I don't know, put in a lambda a sum a1. And although my type checker is complaining, I'm pretty sure this will work. There you go, 3. So yeah, lambdas are also another way to curry stuff. There are some dragons in that area though, especially like with for loops. Functools.partial always works. It's the right call.
Any questions? When would you start like, so oftentimes like you're kind of refactoring your code to match your tests, which I agree these are like excellent refactors. When would you make the call to like, okay, I'm gonna change my actual code to match my test rather than the test match the code, I guess? Or is it just something you think of when you're building, when you're designing for the first time or making updates?
I mean, I think like a good place to think about I need to change my code to match what I'm testing is when you look at the test and you have no idea what's going on. I think that's a good place to say, okay, well, I probably need to do some refactoring here before I can like add my feature because I just don't understand what the test is doing and I can't change it without the risk of breaking everything. Yeah, I think like my general guidance as like when to go down this route of like injecting dependencies and that sort of thing. It's like you don't need to do trivial stuff like this. Like if you have a function called sum, you don't need to be injecting every single function into your other function. It's going to be a mess, right? You could take this to some absurd extreme, but it just doesn't make sense to. I think the good places to do it are when you're doing like I/O that you can't do in your CI server or in your automated tests, because I mean, if you're just making an HTTP call to like google.com, it'll receive that no problem. But if you're like making an HTTP call where you're paying per call or where it's like slow, or if you're doing like some sort of computation, like if you have a machine learning model that you're running, that would be a good place. Like unless you're actually trying to test the machine learning model, you probably don't want to run it in your tests. And so you could, again, do the same thing in like monkey patch, like, I don't know, scikit-learn some tree.predict or something. Or you could just like have a small machine learning model that has one hidden layer instead of a billion, and pass that into your tests. What else? I think there's like interesting cases like databases are an interesting one. Because like if you use Postgres, you can just spin up a Docker container and actually test against Postgres. And then, yeah, you don't need dependency injection. If you can just run against the real database, great. Now, if you have a lot of business logic tests, though, and they're each hitting the database, and that's adding, 500 milliseconds to each of those unit tests, and you have a lot of them, you may want to do dependency injection just so you can swap out some sort of like in-memory thing, kind of like I did with Bucket, instead of the database, even if you could actually test against the database, and even if it doesn't cost you anything, just because it's going to make everything terribly slow. So yeah, I mean, slow things that cost money are good reasons to, think about like, okay, I can't actually test with the real thing.
Makes sense.
Oh, sorry, couldn't see it.
Sorry. I just wanted to highlight one of the other nice things about the way that you created your bucket class. You kind of glossed over this, but if you were to go from the Google storage, whatever it was, to like AWS something, you've kind of created your facade with the bucket class, and then you can like create a protocol class or something, and now the way that you interface with both of these will be the same. You can drop one in and out without really actually having to change any of your main code.
Totally, yeah.
Inject to this guy right now.
Yeah, and you can get into like all kinds of fancy stuff like dependency injection containers and whatnot. But like one pattern I used is like having an AWS bucket and a GCS bucket, and in my like main function where I start my program, I check an environment variable that says am I in AWS or Google Cloud, and then I import the corresponding bucket and I just pass that object around everywhere and use that. Any other questions?
Yes. Andrew, Adrian, a round of applause. I'd code, that's a tough one, and we have that one.
Yeah, I thought it might be a smaller.
You want You should have seen the link. Do you want to close this off, Heather? You want to close this out, or I can do it, or? I must do something. Or,
All right, well, I just want to ask, has this been the best meeting ever?
Hell yeah.
All right, so I think that concludes our talks for the evening. Do we have plans for an after party?
we could find something around here.
Yes, all right, after party at Monk's.
Thank you, Spot Hero.
And thank you, Spot Hero, for hosting us.
You want more food, please take care.
You heard the man, eat pizza.
Yes.